I hope you can see my screen now. Am I right?
Yes.
We can see it.
Okay. Okay. I hope we finish this one. Am I right?
Yes, doctor, we solved
We finished
79
and
and
we finished. Yes. So let's we come for our this question. Read the question. What is given in this question? I can say okay. In figure 624, it is not 624, it is 623. So I have to change to 24. In figure 624, a force P act on a block weighing 40 Newton. A block is initially at rest on the plane, inclined at an angle of 15 degree to the horizontal. Brother, see the diagram. I have a block and this block is exactly sitting on the inclined plane and we fix the angle 15 degree and it is exactly on the horizontal, exactly on the inclined plane above the angle of 15 degree, and the upside of the plane is positive x-axis, and the coefficient of the friction between the block and the plane is given as mu s value 0.50 and mu k value 0.34. In unit vector rotation, you have to give the frictional force acting on the block from the plane. So you are going to apply three different forces to this block, and that force is nothing but our P force, P vector force, and it is a vector force. So what is going on here? You can see here. First of all, we have to draw the free body diagram. So we are going to find our frictional force. Could you please tell me what is your normal force? Which one will be your normal force? Brother, I'm asking the question to you only.
The first
the
one.
perpendicular and the
Yeah, the perpendicular to the surface. The perpendicular
Yes.
to the surface is your normal force. Am I right? So this is my normal force. So here, this is my force due to gravity, or it is nothing but our weight of the block. So this is my the horizontal component of this plane, and this is my vertical component of the plane. So this is my theta. So if this is Fn, this is my weight of the block, and this is nothing but weight cosine theta, and this is my weight sine theta. Clear? And then if the block is moving from upside to the downside, this is my positive x, this is my negative x. So my friction force will be acting in this direction. So this is my frictional force. Clear, brother? Understand?
Yes.
Okay. Let's we just start from the equation. So we are going to find our normal force, because why? You can see here they give the information. Better we can write what is given in the question. The weight of the block is given, which is nothing but 45 Newton, and then angle is given 15 degree. Mu k, mu s value is given. Mu s value is 0.50 and mu k value is 0.34, and then any other information? Okay. Now you have different questions here. When you apply P forces as minus 5 Newton, what will happen? If you apply minus 8 Newton, what will happen? Why this minus represent? Because you are applying the force in the negative of x. So if this is positive, this becomes negative of x. Am I right? Am I right or not? If this is positive, this is negative. That's what your force will be acting in the negative direction. But for our case, I'm going to take the magnitude, because from the picture it's clearly shown that the force is applied to the negative direction of the x. So here they give the information about the mu s and mu k. So you are going to use the static frictional force. So what is our formula for static frictional force? Static frictional force is nothing but mu s multiplied by Fn. Kinetic frictional force mu k multiplied by Fn. So if you want to work out this for frictional, you must need the normal force. So my normal force, upward force, which is equal to downward force. So first of all, I'm going to find the normal force. What is my normal force? My Fn, which is equal to W cosine theta. So my W is given as 45, cosine of my angle is 15 degree. When you just work out, you will get 43.5 Newton. Clear? Once I just found, then immediately I have to go for finding the maximum static frictional force, because in the theory what we studied, brother, if any object is moving on a plane, initially it has the static friction, and later on the applied force, based on applied force, your static friction will be converted to kinetic friction. So in this case, first I am going to find my static maximum frictional force. That means my static maximum frictional force is given by the formula mu s multiplied by Fn. So what is the value of Fn? Fn we find, and mu s value is given as 0.50. So 0.50 multiplied by my Fn value is 43.5. So in such a case, what you will get? I will get the answer
21.75.
75 Newton. So I can just take 21.7 Newton. So this is my maximum static friction force. Brother, listen carefully. When you are applying the force more than the static friction force, then only the object will move. Till that, what will happen? The object will not move. So here there are three different forces is given. What are the three? -5, 8, and 15. So I'm going to consider only the magnitude of the P forces. That means the P vector force is given negative, but I'm going to consider only the magnitude. So if I want to find the block movement, I have to consider this equation. I have to consider only these equations. Am I right? Am I right?
Yes, sure.
Yes.
So what I'm going to do?
Yes.
I'm going to write the equation as, so my frictional force, which is equal to P plus W sine theta. I'm going to consider only the magnitude of the P, because here you have -5, -8, and -15. So it's not a matter for us. We are going to only find the friction force. And why this negative is given? Because the block is moving in the negative direction. That's what they give the value of P as -5. Clear? So don't worry about these things. I am going to consider only the magnitude. Now what I'm going to do, I'm going to substitute the value of P first. What is our first value of P? Our first value of P is 5 Newton. Better I can use the next slide. So I can just write my static maximum frictional force is 21.7 Newton, and the first force, I just write the equation as my force, which is nothing but magnitude of the P plus W sine theta. Now my P value, what is my P value? My P value is -5 Newton I cap. So I'm going to substitute this value here. So if you substitute, what you will get, brother? My static friction force, which is equal to the magnitude of -5 is positive of 5, plus my W value is 45, sine of, I think, what's the angle? 15 degree. When you just work out, what you will get? I think 16.65 you will get. Am I right? Am I right or not? Brother, do you have a calculator?
Wait, teacher, I work it out now.
Yeah.
Yes, please. Better we check the answer. That will be quite good. So
You get, yes, teacher, 16.64.
6.5. 6.5. The
Yes,
unit
yes.
is Newton. Okay,
Yes.
now you can see, brother. Now you can see here the most important thing. This is my friction force, and what is my maximum static friction force? 21.7. But here I got only 16.65. Which one is greater, brother?
Yes,
The maximum.
Said.
The maximum static friction is greater still now. Is the object is moving now? When you apply 5 Newton?
Believe no, it's static.
Still the static frictional force is acting on the object. Now let's we go for the second force. What is our second force? My P vector force is minus 8 Newton I cap. Again, I'm going to substitute this value in this equation. If you substitute, what you will get? My static frictional force, which is nothing but the magnitude of this negative 8 plus 45 sine of 15 degree. So if you substitute 8, what you will get? I will get 19.65. So I will get 19.65 Newton I cap. Now you can see this value and this maximum. Still your static frictional force is greater, so your object will not move when you apply 8 Newton I cap vector to the object. Let's we go for our third force. What is our third force? Our P value is minus 15 Newton I cap. Again, I am going to substitute this value in this equation. So what I will get? My static friction force, which is nothing but the magnitude of 15 plus 45 sine of 15 degree. So what you will get? If you substitute 15, you will get
26.65.
Yeah, 26.65 Newton I cap. Now you can see this force is greater than this force. Am I right?
Yes,
Yes.
teacher.
Am I right? So now what happened to the block? Now the block will start to move. Understand?
Yes. Yes.
Now, when the block is about to start, your static friction is converted to kinetic friction. Am I right?
Of course.
So now you have to find what is your kinetic friction. What is the formula for kinetic friction? My kinetic friction mu k multiplied by Fn. So my mu k value is given in the question as 0.34. My Fn value is 43.5. So 0.34 multiplied by 43.5, I think, which gives you 43. That means 0.34 multiplied by 43.5
We'll
gives
give you
me
14.79.
14.79. I can approximately write as 15 Newton. Clear?
Yes.
Clear, brother? So each and every cases, first of all, you have to find, because in the question they clearly mention about the static frictional force. So you have to check force by force. First force is 5 Newton and second force is 8 Newton. When you apply 5 Newton, your value is 16.5. So still it is smaller than the maximum static frictional force. When you apply 8 Newton, you got 19.65. Still it is smaller than the static frictional force. But when you apply 15 Newton, you will get a 26.65 Newton, and it is greater than the static friction force. Now what happened? Your block will be accelerating towards the negative direction of the x. Our negative is not a matter, but the block is now started its moving. Am I right? So it will be about to start. Now once it starts, we are going to find our kinetic friction. So our kinetic friction value is given in the question, and the function, the normal force is given. We already calculated. When you multiply, you will get this value. So this will be the frictional force. Clear?
Okay, teacher. With the 26.65, you forget the I cap. The cap over I.
Oh, this is I cap. Okay, so I forget. Okay, good. And also here also you have to, because you have to give the answer in terms of unit vector. Clear?
Okay. Yes.
Clear, brother?
Yes, teacher.
Okay, let's we go for our fourth question. What is given in the fourth question? Read the question. In figure 627, a 15 kilogram sled is attached to 2 kilogram of sandbox. So this is your sled. So the value of the sled is given as 15 kilogram. And what is the mass of this sandbox? 2 kilogram. And this is connected by a string of negligible mass. So no need to worry about the mass of the string. It is smaller value and it is passing through the frictionless pulley. And this mass is also negligible value. The coefficient of the kinetic friction is given. What is the coefficient of kinetic friction? Mu k value, and this value is given as 0.040. And we are going to find, first question, we are going to find what is the acceleration of the sled, and the second question, we are going to find what is the tension produced on the string. So these two informations we are going to find. But if you want to find this acceleration and tension, first of all, you have to draw the free body diagram. Okay, brother, listen carefully. I am going to draw the free body diagram for the sled first. So I have object. So this is my normal force. Am I right? This is my normal force. And this is my force due to gravity. Let us I take M1 this. And I take this is M2. So if this is M1, my force due to gravity will be M1 multiplied by G. And here you are connecting with a string, tension will be produced here. And when the object is moving to the right hand side direction, your friction force will be acting in this direction, and that friction is nothing but our kinetic friction, because in the question there is no information about the static friction. Only they give the information about the kinetic coefficient of kinetic friction. So the friction happened on the block, on the sled, is nothing but our kinetic friction. So this is our free body diagram for the sled. Now if you want to draw the free body diagram for the sandbox, this is our tension produced on the string, and this is our force due to gravity, which is nothing but M2 multiplied by G. Clear? Understand? Clear?
It's clear.
Okay, now brother, for this first equation for sled, listen carefully. We are going to find the acceleration. First I am going to write the equation for the sled. I am going to write the x component force. What are the x component force you have for the sled? Tension as well as the friction force. So how you have to write? How you have to write? Because your block will be accelerating only in this direction. Am I right? Am I right or not? So I have to write my tension minus my frictional force, which is equal to my Newton's second law. What is Newton's second law? M1 multiplied by A. I am going to write, this is my first equation. Likewise, I am going to find my y component forces. What is my y component force? My upward force, which is equal to downward force. Therefore, my normal force, which is equal to M1 multiplied by G. So I am going to take my second equation. Likewise, I am going to write the same equation for the sandbox. So for sandbox, what is your x component force, brother? What is your x component force? Is there any x component force? Is there any x component force for this diagram?
We have the sled moving to the right.
Brother, listen carefully. I am writing the equation for the sandbox. Just answer my question. Is there any x component force for this diagram?
Yes, and I think
No.
that's right.
No, there is not.
Oh no,
Yeah.
number 2, no. Yes.
Number 2, there is no x component force, so I can just make this is my third equation. But the y component force it have, because what is your y component force? My y component force is nothing but m2g minus tension, which is nothing but my acceleration m2 multiplied by a. So I am going to take, this is my fourth equation. Understand, brother? It's clear?
Clear, doctor.
Okay.
Clear.
Now we are going to find the acceleration and tension. Brother, listen carefully. First of all, what I am going to do, I am going to find the acceleration. See the 4 equation. In how many equations you have the acceleration? In first equation, I have the acceleration. In fourth equation, I have the acceleration. Am I right? Remaining 2 and 3, there is no acceleration information. So what I am going to do, I am going to add equation 1 and 4. Both left hand side and the right hand side. So what is in the left hand side? My left hand side of the first equation is T minus Fk, and then left hand side of the second equation I am going to add plus M2G minus T, and then right hand side of my first equation is M1A. My right hand side of the second equation is M2A. Am I right? Am I right or not? Because what I did, I add equation 1 and 2 both left hand side and right hand side. So I just add this term, and then I add this term and this term. Clear?
Yes, teacher.
Okay, now you can see I can just cancel this plus t and minus t. Am I right? So what is remaining? The remaining term is minus Fk plus m2 g, which is equal to, I can take the acceleration common, m1 plus m2. I can write like this. Am I right? Am
Yes,
I right?
teacher.
Okay. Now in the second slide, I'm going to write the same thing. Minus fk plus m2g plus m2 multiplied by g, which is equal to acceleration multiplied by m1 plus m2. We are going to find the acceleration, but before that I am going to substitute the formula for the kinetic friction. What is the formula for kinetic friction? We already have the formula for kinetic friction. What is the formula for kinetic friction? Mu k multiplied by
MK.
Fn. Am I
Fn.
right? And what is this
Yes.
Fn? Fn is nothing but, see the second equation. What is my Fn here? What is my Fn? My Fn is m1 multiplied by g. So my Fk, which is equal to mu k m1 g. Am I right?
Yes.
I'm going to take this, I'm going to substitute here. So I'm going to take this Fk, I'm going to substitute here. So if you substitute, what you will get, brother? My term becomes mu k m1 g plus m2 g, which is equal to a multiplied by m1 plus m2, and we are going to, I'm going to take g as the common term. So if I take g outside, inside the bracket, I have mu k m1 plus m2, which is equal to a multiplied by m1 plus m2. And I'm going to keep this term here. I'm going to move this m1 and m2 to the left hand side of the denominator. So what I will get, my a, which is equal to g multiplied by minus mu k m1 plus m2 divided by m1 plus m2. Am I right? Am I right?
Yes.
yes,
You are right.
Okay. Okay. Now, A,
Find
I'm going to substitute
acceleration.
now I am going to substitute the value of G. The G value is 9.8 multiplied by my mu K value is given in the question, which is nothing but 0.04. My M1 value is 15 kilogram. My M2 value is 2 kilogram divided by mass of 15. Mass 1 is 15 kilogram plus mass 2 is 2 kilogram. When you just work out with your calculator, I got 0. What answer? I got 0.807. 0.807 meter per second square I got. So this is the answer for the first question. Am I right?
Yes.
Okay, now we got the answer for the first question. Second question, we are going to find the tension. We are going to find the tension. So, okay, you can see here in which equations we have the tension information. Equation 1 also we have the tension information. Equation 4 also we have the tension information. Either you can use equation 1 or equation 4. Both will give the same answer. But in the slide, I use the fourth equation. But for the right now, I'm going to use the first equation for cross-checking the answer. Understand? Clear? For example, you can see here, brother. Here I am using fourth equation. Am I right? Am I right? Here I am using fourth equation.
Yes, teacher.
But for this calculation, I am going to use the first equation. Let's cross check our answer. What is our first equation? T minus Fk, which is equal to m1 multiplied by a. So we are going to find the tension. So I'm going to move the term to the right hand side. So what I will get, m1 multiplied by a, this negative becomes positive Fk. What is our Fk? Our Fk is this. I'm going to substitute here. So m1 a plus mu k m1 g. Now substitute the value. We know the answer for is m1, which is nothing but 15, multiplied by the acceleration just before we find, which is nothing but 0.807 plus my mu k value is 0.04 multiplied by f1 value is 15 multiplied by g value is 9.8. So if you just work out, what you will get, brother? I got 17.98.
1 minute.
got-
I just calculate.
Yes, please calculate. I got 17.98. So approximately how I can
Yes,
write?
teacher.
I can write
Correct.
this as 18 Newton. I can approximately write this 80 Newton. Am I right? Okay. Let's we just check our answer. Here I used equation. Here I used equation 1. Am I right?
You are right.
Am I
Yes,
right?
teacher.
Okay. Now in the slide I use equation 4. You can see answer. Both equation gives you the same answer. So what you understand from this from this question, either you can use the first equation or either you can use the second equation or fourth equation.
You
It will
will
give
get
the same answer.
answer.
Same answer. Same answer.
Yes.
Understand? So this will be the this is one of the important questions. So please take practice. The most important thing, how to draw the free body diagram. That is very, very important. Clear?
Okay. Clear.
Clear.
Thank you,
Okay.
doctor.
Okay, brother. One more important thing. I think last day we solved this question. Am I right? Last day we solved this question. We found the answer is 0 Newton for the third part. Am I right?
Yes,
Yeah.
teacher.
Am I right? Brother, actually the direction. What is the direction? If there is no normal force, because our normal force is 0. So if there
Yes,
is no
so
force,
there is no direction.
there will be no direction.
Ah,
Clear? Clear, brother?
Clear.
Actually, from this side, listen carefully. If your n value is positive, then the direction will be upward. Okay? If your n value is negative, the direction will be downward direction. If there is no force, then no.
No direction.
Keep this information in your mind.
Okay, there is no left side and right side.
No, because they said it is exactly in the top of the hill. So they don't give the information about whether it is moving left hand side or right hand side. They just tell the roller coaster is exactly sitting on the top of the hill. You can see the question. What is mentioned here? It is exactly on the top of the hill, top of the
Yes, a roller coaster. Yes.
Understand? So by this, I
Yep.
think your chapter 6 is finished. That means we are exactly ready for our ready for our midterm exam. Your midterm exam portion is from chapter 1 to 6. Brother, you are going to write the exam in the campus, not online exam. So please remember one important thing. You are going to come to the campus to write the exam and you are going to work out each and every problem on the paper. So please don't forget to bring the calculator. Understand? When you have the physics exam,
some doctors said because COVID-19 they will use multiple choice to avoid COVID-19.
No, brother. That is the multiple choice question is only for the online exam. But for the offline, but for the campus exam, generally we will give the question like solving problem. That means you will give the paper with some space. In that space, you have to work out the question to get the answer.
Okay, thank you.
That will be quite good. You know why? When you write something, at least you will get some mark for the steps.
Yes.
If it is 1 mark question, either it will be 0 or 1. So it is really hard for you. Sometimes sometimes you will get more marks, sometimes you'll get 0 mark in the multiple choice question.
It's better, yes.
Clear?
Doctor,
So please.
clear.
Yes.
I forget. Hey, doctor, next week we will go to chapter 7.
Inshallah. Inshallah.
But,
No, I'm going to. What's the time? What's the time right now? What's the time right now? I think it's 9:30. Am I right?
Yes.
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 Okay. What I'm going to do? I'm going to open chapter 7. At least small information I will give you right now. Just a small basic information. Okay.
Okay.
Just small information. So don't worry.
Doctor, before you
Yes,
open the slide,
Okay.
can you just delay the deadline for the assignment?
Why? Why? What's the reason?
Because we have other assignments, so we have pressure. It's okay if just delay it for the Saturday.
Is
It's
this
enough.
Mr. Hatim?
For the introduction?
What's your name? Your name is Hatim?
No, Muhammad.
Muhammad. What's the problem, brother? It's very easiest question. What's the problem?
Yeah, for the other
More assignments,
courses.
teacher. And,
More assignments, brother. Your full-time job is studying. Am I right?
No, we have a live teacher.
Brother, don't say a lot. When you just finish. Okay, when I just put this question last week. Am I right?
This week?
No, last week. During the weekend, I put the question on the blackboard. You can go and check the date. So that means you want to finish your work at the extreme last minute. Am I right?
Not like that.
Huh? Don't do like this, brother. Once the work will be given, try to finish your work immediately. That will be easy for your future work. If you keep on dumping your work again and again, what will happen? Finally, you will get more problem. Because every teacher, they are busy. Because, brother, listen carefully. You are talking about in your point of view, but you can just consider my point of view. I have 6 lab section. I have 2 theory section. Apart from that, every week I have to grade 60 lab papers. Each section 10 students, 60 lab papers. And apart from that, assignment 30 plus 30, 60. And 30 students, they just imagine. And apart from that, we have to prepare the class. We have to prepare for the lab work, and then we have to prepare for the exam preparation. So many things are there. You should remember these things, brother.
Okay.
Teacher.
Okay,
I want to ask you about-
okay. Listen, I can do one thing. I will just extend it 1 more days. Friday, you have to submit. Understand?
Okay, thank you.
Thank you.
Okay, Friday, inshallah, I will change the time right now. Inshallah, once I finish the lecture, I will change the time for both the section. Friday, 6 o'clock.
Thank you,
so
Doctor.
much.
Okay, thank you.
Okay, teacher, did you receive my lab report or not?
Did you send to my email ID? Basam.
Yes, but I don't know if it is received your email or not.
No. I don't receive any email from your side.
Okay,
Okay,
I
you can
send it on WhatsApp also. If you
WhatsApp, how I can just grade it, brother? I need the documentation. You can do one thing after the lesson. Listen. After the session, inshallah, I will give my private email ID. You can send that copy to that ID.
your email ID.
Yes, not college email
Okay.
ID. It's my private. Huh?
Okay.
Okay, brother. Let's become for at least 1 or 2 slides. We will finish from this topic. Just to see, the title of chapter 7 is kinetic energy and work, and we already deal with the formula in the lab. Am I right? In this experiment 5, we used the gravitational potential energy. That is the title of your experiment 5, and in that we use the formula for the kinetic energy. Okay, we just come to the contents. What are the things we are going to study from this chapter? We are going to study what is work, what is kinetic energy, basic information, and then we are going to calculate the work done by the external force. So if you want to apply any force to any object, that means you are doing some work. Am I right? And then we are going to study the most important theorem, work kinetic energy theorem. This is one of the important theorem, and 1 mark theory question as well as problem questions will be coming from this 3rd point. So you should be very, very careful. Please prepare well. And then 4th point, we are going to study work done by the gravitational force, and 5th one and 6th one is different. You can see here, work done by the spring, work done on the spring. If you do some work by the spring, then what will be the result? If you do some work on the spring, what will be the result? So these two, you will get the same formula but different sign. And then finally, we will conclude the session with power. Clear?
Yes, teacher.
Okay, I will just start from the first slide. What is given in the first slide? The first slide is a pure theory question. Define work or define energy. So energy, so if you want to do any work, what you need? You must need some energy. So energy is the ability to do the work, and it is a scalar quantity because it gives only the magnitude, not direction. And you can transfer the energy from one form to another form. So when you just transfer the energy from one form to another form, your energy is conserved. What is the meaning for conserved? Your total energy remains the same, because energy can either be created nor be destroyed. But you can transfer the energy from one form to another form. When you just transfer the energy from one form to another form, your energy is totally conserved. That means your total energy in the system remains the same. When you come for the kinetic energy, we know the formula for kinetic energy as half mv square. So half multiplied by mass of the object multiplied by its square of the speed. So if any object is under motion, that object has the energy of kinetic energy. If an object moves faster, your kinetic energy is greater. If the object is not moving, your kinetic energy is 0. So the unit for the kinetic energy is joule, and also the another unit for the kinetic energy is kilogram meter square over second square. You can just use this formula. What is the unit for the mass? The unit for the mass is kilogram, and what is the unit for the speed square? Meter square over second square. So the another unit for this joule is nothing but kilogram meter square per second square. Now forget about this slide, and this slide is the basic information. Inshallah, you will just work out in your home. I will explain this information later. Inshallah, in the next class, I will just tell you this information. Now, when you come for the work, all these informations are related with your theoretical point of view. So what you just come from here, what you understand from this, you can see here, the work is positive. When your work will be positive, because work is the scalar, it also gives you only the magnitude, no direction. So it's a scalar quantity. So what is when your work will be positive? Your work will be only positive if the kinetic energy is transferred to an object by the external force. For example, you have an object, you are applying some force, external force to the object. When you just give some external force to the object, that means you are transferring the energy to the object, from your body to the object. When you just transfer the energy from you to the object by means of external work, by the time your work is positive. When your work will be negative, reverse. If the kinetic energy is transferred from the object, in other words, the negative work done. If any object kinetic energy decreases, that means you are extracting the kinetic energy from the object. So that means what will happen? By the time your work will be negative. So the unit for the work is also joule. Okay, let's come for solving this problem. Brother, here the information is given. I'll just tell you the outline story. You can see here. I can just draw one diagram. That information is given in the question. I have two trains, two objects. One train will be here. What is maybe train, brother? The train will be moving from one point to another point. Am I right?
Right.
Okay, so I have two locomotives. Better I can just take the example of train. So I have two trains, and these two trains mass weight is given. What is the weight of the train? The weight of the train is given as, what is the weight of the object? Weight of the locomotive. Locomotive I'm going to take as a train. What is the weight? 1.2 multiplied by 10 to the power of 6. So that means the weight of the object is given as 1.6 multiplied by 10 to the power of 6 Newton. What is going on here? This train is moving towards this direction, and this train is moving towards this direction. By the time it is about to collide face to face, that means the distance from this point to this point is 3.2, and the distance from this point to this point is 3.2. So 3.2 plus 3.2 gives you
7.
6.4. Am I right? So how much distance it's covered? How much distance it's covered? 6.4 kilometer. So that means half of the path will be covered by the first train, half of the path will be covered by the second train. That means here 3.2 kilometer, here 3.2 kilometer. Understand? So total is 6.4. What's the total? 6.4 kilometer. If you convert the kilometer into meter, it is nothing but 6.4 multiplied by 10 to the power of 3. Am I right? Meter.
Right.
Okay, now the distance covered by these two objects is only 3.2 each. Am I right? So what we are going to do, first thing, we are going to find what is the speed. So when it come and hit, what will happen? It will initially, it is coming with a speed. Initially it is rest, and finally it will be moving with some kinetic energy. So what we are going to find, we are going to find what is the kinetic energy of each vehicle, each locomotive, each train. So we are going to find the kinetic energy of this train, and we are going to find the kinetic energy of this train. That will be our question. And the acceleration of this object is given. What is the acceleration? The acceleration is given in the question as 0.26. So the acceleration is given as 0.26 meter per second square. Now, brother, listen carefully. If you want to find the kinetic energy, this is the formula. So my kinetic energy, which is equal to half mv square. Am I right? Am I right?
Right.
Okay. So that means here how many vehicles we have? we have two vehicles. One is the first train. The first one is the first train. The second one is the second train. Am I right? So when these two trains are moving, both trains have the kinetic energy. Am I right?
You're right, teacher. Yes.
So I have to multiply by 2 here. Am I right? Because what they mentioned in the question, what is the total kinetic energy of the two locomotives? See the last line. What is the total kinetic energy of the two locomotives? Locomotives is nothing but our train. Clear?
Clear.
So we are going to find the kinetic energy, and after we find, we multiply by 2 because we have two trains. Okay, if you want to find this kinetic energy, first you have to find the mass, and then second you have to find the speed. So for finding the mass, what I am going to do, I am going to take the mass from this weight. So we know the formula for the weight. What is the formula for the weight? Weight which is equal to mass multiplied by gravity. Therefore, my mass which is equal to weight over gravity. Am I right? Am I right?
What teacher? I didn't hear well.
No, for example, if you want to calculate this kinetic energy, two things you need. One is mass, second one is speed. Am I right?
Yes, not speed, velocity, direction.
Oh, well, we have speed. Okay, forget about the way. Here we are talking about only the magnitude because
Okay.
it's moving in only one direction. So I am going to consider this is a speed. Understand?
Yes.
Okay, now for finding the mass information is not given in the question. Only weight is given. What is the weight? The weight is given as 1.2 multiplied by 10 to the power of 6 Newton. Am I right?
Yes.
So I can find the mass of the train by using the formula W, which is equal to mass multiplied by gravity. Therefore, my mass is equal to weight over gravity. So what is my weight? My weight is 1.2. My G value is 9.8. By that I can find the mass. Am I right?
Yes, teacher.
Okay, now we find the mass. We find the speed second. So I am going to use the third equation. So V square, which is equal to V naught square plus 2 into A into x minus x naught. And x minus x naught is nothing but the covered distance is 3.2, because when the object comes here, both will cover the distance of 3.2. Am I right? So the distance covered is 3.2 kilometer, means 3.2 multiplied by 10 to the power of 3, and acceleration is given as 0.26 in the question, and your initial speed is 0 because it starts from 0. We don't know what is our final speed. So my initial speed is 0. So when I substitute, I can find the final speed of the trains. Am I right?
Yes.
So once I find the speed as well as the mass, I can easily find the kinetic energy. Am I right? What is the formula for kinetic energy? Half mv square. So here we have the mass. This is our mass. This is our final speed. Am I right? Am I right or not?
You're right, teacher.
So I'm going to substitute this formula. I substitute the value in the formula. By that time, I can find my total kinetic energy. What is my total kinetic energy? This information is for both the train. This value is for both the train. Suppose in the question, if they are asking find the kinetic energy of only one train, what you have to do? You should not use this.
Yes, because this is for the two trains. If you want to use one,
So if you want to find answer for only one train, no need. You can directly substitute the formula as half mv square. That's it. Clear? Okay, brother. Up to this, I will stop the lecture. Inshallah, we will cover the remaining portion in the next week.
Okay.
Understand? Understand?
Understand.
Okay, brother, listen carefully. We are exactly moving on our phasing schedule of our syllabus. So don't worry about the chapters. We are exactly covering our chapter based on our syllabus. So, inshallah, we will cover the entire chapter by time. Okay?
Okay.
Okay, brother. I think right now the time is, yes.
I just have a question relative to assignment.
Okay, please ask me.
The question number 4.
What's the question? Just read the question.
Calculate I plus j cap
Okay.
multiply with I minus
Hmm.
j multiply
Okay.
with k.
Wait.
This
Wait. I
from
can just
where?
open. Wait. I will tell you, brother. Please. This is your
Thank you.
homework. Am I right?
Yes.
You're talking about this. Am I right?
Yes.
Okay. What you have to do here, brother? What you have to do? What is the value of I? J. Here the value of I is 1. Am I right?
What?
Value of I is 1. Am I right? 1I plus
Yeah.
1J. So first
Yes.
what you have to do? First you have to write this. First you have to find what is given in the bracket, and you are going to first you find this part. Okay? First you find this part, and then second you find this part, and then you are going to find the dot product. Here each value of I is 1. J value is 1. K value is 1.
Okay, doctors. How we calculate I
We
plus
already
j?
I plus 1 plus 1.
1 plus 1 2, but here
Okay.
different direction.
What is direction, brother? Here my I value is positive, J value is positive. Here my I value is 1, J value is minus 1. You don't know IJK, the determinant form?
It's relative to the square IJK, right? In the chapter 3, right?
You don't know this method?
Yes.
What is the value of I? What is the value of J? What is the value of K? Second vector. First you find the cross product, and then you find after you find this answer, make the dot product. Finish. It's very easiest question.
Okay. Thank you, doctor.
Clear? It's very easy question.
No, I
So
understand.
it is the concept, right?
Yes, you are going to use the cross product because here you can see the cross is symbol. The cross symbol is here. That means you consider this is your A vector, this is your B vector. A vector have X component, Y component, and Z component. B vector has the X component, Y component, Z component. So you can easily find the A cross B method. Am I right?
We use the doctor. Shall you please go to chapter 3 faster?
Chapter 3.
Yeah.
You mean slide?
Slide, yeah.
Wait. What happened to my chapter 3? Once I just put everything, it will be changed. Okay, better I can open the PDF file.
Yeah, same as me. When I
Okay.
write something, they're not open.
I don't know, something happened. Okay, I can just resave this. Okay. Where, brother?
Go to the last slide.
Theory or problem?
Theory, yeah. I mean,
The
Okay.
cross product. Maybe.
cross
Okay,
product.
Yes, here.
Yes. Yeah. Here, what you mean? You mean you mean in the right? We use this concept, right?
You first you have to use this concept, this one.
Yeah.
Okay. So by
Okay.
using this, once you find these things, you will get some answer. After you find the answer, you are going to find the dot product. This answer,
we
this
just
answer,
came on, right?
yes. First you find the cross product, you will get some answer, right?
No, I understand.
Listen, brother. Listen. First you find the cross product for these two. You will get one answer. Am I right?
Yes.
So with that answer to this answer, you are going to find the dot product.
Yes. Now I understand. Thank you, doctor.
Okay, brother. So, okay, brother, I think time is over. So I have to get ready for my lab classes.
Doctors, we just bring in the lab experiment on Thursday. We just bring experiment 3.
Yes, experiment 3
only.
only. Yeah.
Okay. Thank you, doctor.
Okay, brother. See you, brother. Have a nice day.
Thank you, teacher. Have a
Have
nice
a
day.
nice day.
Thank you,
Okay, see
teacher.
you.
Have a nice day.
Yes, brother. You too. Thank you. Thank you so much.